Good morning, guys. So today we're talking about tangents, and what you'll see here is the definition of tangent and point of tangency. So a tangent is a line in the same plane as a circle that intersects the circle in exactly one point, called the point of tangency. So if you look here, we have circle C, and then you have line AB. And AB is intersecting the circle. It's touching the circle at one point, and that point is called the point of tangency. So what we can see here is that line AB is tangent to circle C, and specifically it's tangent at point A, which we will call the point of tangency. Next definition we have today is a common tangent, and a common tangent is a line, ray, or segment that is tangent to two circles in the same plane. So if you see right here, we have two circles, circle F and circle G, and then this one line, we'll call it line AB, is tangent to both F and G. So that same line is tangent to two different circles, common tangent. Our first theorem is theorem 10.10, and it reads, in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So what this means is we have to have a radius to be able to do this, but if you have a radius drawn and you have this line, it's going to be tangent if they're perpendicular. And remember that perpendicular means it has a right angle. So if we see that right angle, we then know that these two lines are perpendicular, and therefore it is tangent to the circle. So line L is tangent to circle S. Okay, so our question is, determine whether line GH is tangent to circle F. Remember from theorem 10.10, that would mean that this has to be a right angle, which means we would have a right triangle. Now, one thing that's a little tricky about this, and it doesn't really look like it, which is why it sometimes is confusing, but this 12 is talking about this piece right here. I know that that does not look like it's 12 to scale, but it's marked 12, that's what they're talking about. So we don't actually know this length. However, from a circle's center to an edge is a radius. So if I know that this radius is 6, I also know that this is 6, meaning that this hypotenuse, again, for purposes of pretending it's a right triangle, would be 18. And then our job is just to figure out, is it actually a right triangle? If it is, it's tangent. If it's not tangent. So what we do is we set up Pythagorean theorem with a blank instead of an equal sign. So we have 6 squared plus 8 squared blank 18 squared. And 6 squared is 36 plus 8 squared is 64. And then 18 squared is 324. So 36 plus 64 is 100. And we have 324. So we would not say that that is equal. This would actually be greater than. So this is not a right triangle, so no, GH is not tangent to circle F. And that would be our answer. Okay, for our second example, we have the find the value of x, and the instructions are going to tell you every time to assume that the segments that appear to be tangent are tangent. So what that means is that BC is actually tangent, whether we are assuming it or not. It's telling us to assume it, so it's tangent. What that then tells us is that this is a right angle, and so we're just solving for a missing side of a right triangle. So we did this with the Pythagorean theorem. So we would set this up, x squared plus 14 squared equals 17 squared. Notice on this one that 17 is marking the full side, so we don't have to put x right here and add it to it. 17 is the full length of the hypotenuse. So we're going to go ahead and work Pythagorean theorem. So we have 14 squared, which is 196, and 17 squared, which is 289. We'll subtract 196 from both sides, and that gives us x squared equals 93. We'll take the square root and get x equals, and you could leave the square root of 93, or you could do a decimal and get 9.64. We'll do 2 decimal places. So we're going to say that x equals 9.64. Okay, for B, again, we're assuming that the segments are tangent, so we can add in this right triangle again. What's different this time is we actually don't know the full length. So we would just add these together and you'd have 2 plus x, or x plus 2. And then if from R to the edge is x, we also know that this is x. So we're still going to do Pythagorean theorem, it's just going to be a little bit more involved. So we have x squared plus 4 squared equals 2 plus x squared. So we have x squared plus 4 squared is 16, and then 2 plus x squared, if you want we can go over to the side, but to square something, it means you're multiplying it by itself. So you're going to have to recall some algebra here. So 2 times 2 is 4, we're FOILing, plus 2 times x is 2x, plus x times 2 is 2x, plus x times x is x squared. So it's 4 plus 4x plus x squared, and that will replace right here. Again, if you had x plus 2 instead of 2 plus x, you'll have the same answer, but you might have these two switched. So we have 4 plus 4x plus x squared. And then our job is to start solving for x. So if I subtract x squared from either side, they're both just going to cancel. So now what I see is I just have 16 equals 4 plus 4x. So I'm going to subtract 4, and that's 16 minus 4 is 12, equals 4x, divide by 4, and then we get that 3 equals x. So our x value on this one is going to be just a nice round 3. Our next theorem is theorem 10.11, and it states if two segments from the same exterior point are tangent to a circle, then they are congruent. So what that means is if line AB and line CB are both tangent to circle D, and they share this point out here, this exterior point, AB is now equal or congruent to CB. For example 3, again, we're just finding the value of x, and we're told that it's okay to assume that segments that appear to be tangent are tangent. Again, it's telling us that so that we know that it's okay to assume it. So what we know from theorem 10.11 is that since both RQ and RS are tangent to the circle, as well as they share a point, that means that these two tangents are congruent. So we just set them equal to each other and solve. So we have 3x plus 8 equals 26. Subtract 8. And we have 3x equals 18. Divide by 3. X equals 6. So our answer for example 3a is just x equals 6. Okay, so part B, same thing, setting those two lines equal to each other since we know that they are tangent and they share that point. So we have 3x plus 6 equals 2x plus 9. I'm going to subtract 2x from 3x. That gives me x. I'm going to subtract 6 from 9, and that gives me 3. So again, short, easy answer, x equals 3. Okay, for our last example, example 4, we're told that quadrilateral RSTU is circumscribed about circle J. So that just means that the circle is inside of that shape. And it's saying that if the perimeter is 18 units, we need to find x. Well, what we just learned is that whenever two lines are tangent and share a point, they're congruent. So if this is 3, this is 3. If that's 3, this is 3. This is x, that's x. And if this is x, that one x. So these two are congruent, those two are congruent, these two, and these two. And now that we know all of these parts, perimeter, we would just add them all up, and it should add up to 18. So we have x plus x plus x plus x plus 3 plus 3 plus 3 plus 3. And that adds up to the 18. So we have 4 x's, so that would be 4x plus 3, 6, 9, 12 equals 18. We're going to subtract 12, and we get 4x equals 6. Divide by 4, and we get x equals 1.5. If you would like, you can leave it as 3/2. Just make sure you're reducing that fraction if you want to leave it as a fraction. But x equals 1.5.